This is the DDC264EVM board, which has 4 DDC264 chips on it, connected to a Spartan 3 FPGA and a Cypress FX2 USB controller, and is meant to stream data over from the DDC chips over to the host application on the PC. I have it connected over to this JTAG programmer from Xilinx. That JTAG programmer is used to load this ISE project onto the Spartan 3 FPGA. This allows data streaming from the DDC chips over the USB to the host PC. Now, we can use this demo project in order to demonstrate how this works. It writes 1024 frames of data into a CSV file. If I run it, it finishes, and I open the CSV. And as you can see, we have the data coming out of the DDC264EVM board. Now, this can take up to any amount of data. You just have to change how many frames of data you want, and it will respond with that quantity of data. It can also continuously stream data for as long as you would like. Okay, so now that you've seen it work, how do you work with the code? Well, first, you need to install ISE, which is used to program the Spartan 3 FPGA. This can be done off of the Xilinx or AMD website and is a rather straightforward installation process. From there, you need to open the project, which I have linked in the description, the FPGA firmware specifically, in ISE. That will get you to this. Now, if you do not plan to make any changes, you can just configure the target device, run impact, and flash the Spartan 3 FPGA with the current pre-existing bit stream. Now, if you do want to make any changes, you can edit the top.v file and any sort of sub-files, regenerate the programming file, and configure the target device again. That covers the FPGA side. If you would like to edit the PC side, there are two ways to do so. For more outward-facing / front-end things, you can go and directly edit the demo project and build off of it. This demo project relies on a USB I/O DLL, which is called DDC264EVM I/O. These are both in the same Git repository, and this would be used if you would like to change the protocol or how the data is transmitted over the USB. Please note that if you would like to edit the DLL, you must recompile and add the latest DLL to the demo project before running your new code. As it currently stands, the DDC streaming firmware is very bare bones. The opcode processor was unable to be implemented due to the fragility the necessary command echoes would introduce in order to maintain compatibility. This means that the only setting we can change on the DDC via the C# program is how many data samples we would like to read, which is found in this parameter. As of yet, the remaining parameters would have to be configured within the FPGA firmware in ISE. Now, in a future revision, it would be good to implement a opcode processor in order to restore this functionality, but it would require endpoint changes and regardless would still be incompatible with the TI published software and other projects. Additionally, I have written a document about how this firmware works, and I'm available to contact with any questions regarding setup, further additions, or anything else regarding the TI DDC264EVM board. Thank you for watching.